So typical duplexer. See, duplexer is a device which is going to have two set of frequency. In the transmission band, you see, I'm going to have this response, and in the receiver band, I'm going to have this response. So transmitter and receiver are very closely overlapping, and the loss is going to be just 2 dB. And out of band rejection 30 dB. So in band, I can see how the filters are sharply reducing. See here, it is very sharply reducing, and the other side, it is slowly increasing. So in band, they can reduce up to 2 dB interference. They can remove an out of band up to 30 dB. They can remove the out of band interference, and 20 megahertz offset. So the frequency separation of transmitter and receiver is going to be out of frequency by 20 megahertz. So if an interferer appearing at F1, see F1 is somewhere here. So it is attenuated by 30 dB. So the power will get reduced. It is the critical design and the synthesizer. So this is going to be when you are going to use a duplexer, which is going to work at two different frequencies. So my frequency of interest is F2, but if an interferer is going to appear at F1, then that is completely attenuated by 30 dB. So F1 எவ்வளவு power இருக்கும் minus 30 dB if you do, it will go very less. So that will completely rejected from your in band. So in-band loss is also sometimes problematic as it weighs some amplifier output. So I told you 2 dB in-band loss you have. The 2 dB is an enormous amount of power that is unwantedly wasted whether you have interferers or not. Okay, so 2 dB of loss in a power amplifier is going to be approximately 370 milliwatt in the duplexer. So 370 milliwatt, no, 0.3 watts. That is a very huge amount of power. So that much amount of power is going to be wasted constantly, whether you have in-band interferer or not. So this 2 dB loss will be happening always. Okay, so you cannot say that whenever there is an in-band interferer, you have a 2 dB loss. When there is no interferer, 0 dB loss. Illa. This 2 dB loss is going to be permanently happening in the receiver, whether or not you have an in-band interferer. Out of band 30 dB. That is a very huge. Out of band, it is important for us because we are completely eliminating all the interferers. But in band, we cannot say always there will be an interferer within the band. So that is going to be an unwanted loss of power. So our observation indicates that by properly choosing the modulation and the filter characteristics, we can easily solve this problem. So out of channel energy which is produced cannot be suppressed and acceptably small by design. So out of channel, whatever is going to happen, that is not in our hand. So we should not focus on out of channel interferers. We have to focus only on in band interferers because that is going to drain my receiver power constantly.